Now, what I consider to be one of the hardest parts to understand when you're learning symbolic logic is these quantitative questions. So let's talk about what the negations to these ones are. So the negation to this, I'll write it like this, the negation to this whole sentence, all students will pass this class. Well, let's start with the opposite of all. What is the opposite of all? The opposite of all is not none, it's going to be some. Some students will pass this class. The opposite of passing this class is going to be not passing this class. Some students will not pass this class. So the negation to all is going to be some. The negation to all is going to be some. It implies that if you were to use the word all, it would not be true. And then in converse, the negation to some is going to be all. And then in the second part here, will pass this class change to not pass this class, will not pass this class. And now in the second one, there are no deer on the road tonight. There are no deer on the road tonight. What's the opposite of that? Well, if there are no deer on the road tonight, then all the deer, this means all the deer are not on the road. And since all the deer are not on the road tonight, the negation to that, and this is one of those places where you really have to use your English skills a little bit to deduce what this sentence is exactly saying. If there are no deer on the road, then that's telling you that all of the deer are not on the road. So the negation to that is there are some deer. The opposite of not on the road is on the road. So in every case, the opposite of all is going to be some, where the negation of all is going to be some, and the negation of a not is going to just cancel with the not, or the negation of a sentence without a not is going to have a not. And here it is written out a little bit nicer. If we have a statement, all P's are Q's, the negation is some P is not a Q. That's the negation. That would be proving the statement wrong. And then if the statement is no P's are Q's, the negation of that is some P is a Q. So for example, what would be the negation of the following sentence? No triangles are quadrilaterals. The negation to this sentence would be, take a minute and try to guess what you think it would be. It would be some triangle is a quadrilateral. Why? Because the statement given is kind of the same thing as saying no triangles are quadrilaterals. So none of the triangles are quadrilateral. So the opposite would be some triangle is a quadrilateral. There is some triangle that is a quadrilateral. Now, once again, take a minute and see if you can fill out this table. The statement is all humans are mortal. The negation is some humans are not mortal. The statement is some students do not come to class prepared. The negation would be all students come to class prepared. And then if we have something that has a negation, no students need to see their patients. Well, to figure out the original statement, we just have to negate this, because we all know that a double negative makes a positive. So the negation to this, to no doctors need to see their patients, some doctors need to see their patients. Need to see their patients. And that is negations. So now we have one last thing to learn. Conditional statements. And if then, if P then Q. An example of a conditional statement would be, if I get paid on Friday, then I will pay you back. If I get paid on Friday, then I will pay you back. And let's see what a conditional statement's truth table would be. We have P and Q. We want to figure out what P conditioned on Q is, or P implies Q. And this is our conditional statement. So we have true, true, false, false, true, false, true, false. And now we want to know what P implies Q. Which of these statements would be true? So if you get paid on Friday is true, and then you pay the person back is also true, then you have a true statement here. If I get paid on Friday, in the second case here, true, false, if I do get paid on Friday, but then I don't pay you back, but I said I would, then I'm lying. So this is our false spot. This one's false. Let's see if any of the rest are false. If it's not true that I get paid on Friday, if I were to promise you that I'm going to pay you back if I get paid on Friday, but then something happens, I don't get paid on Friday, my check gets withheld, well, no matter what, I didn't lie to you. I said, if I get paid on Friday, then I'll pay you back, but I didn't get paid on Friday. So I have a genuine excuse. I did not go against my word. I didn't get paid, so I don't have the means to pay you back. So these statements are actually still going to be true. Because if the first piece is false, it doesn't matter what the second piece is. I didn't promise that if I don't get paid on Friday, I'll pay you back. So this is what we're left with. Conditional can only be false if P is true. So for example, if a person is a doctor, then they make a lot of money. If a person is not a doctor, let's assume this is true. Some doctors might disagree depending on what type of doctor they are, but we'll assume that if someone is a doctor, they make a lot of money. Well, if a person's not a doctor, if the P is false, if a person's not a doctor, then they could still make a lot of money. You could still make a lot of money if you're not a doctor. There are plenty of other professions that make the same amount, if not more money. You could still make a lot of money if you weren't a doctor. This is a good example of a conditional statement where P being false means that the second half could still be true. Now let's see if is not P implying not Q equivalent to P implies Q. If I am out past 10 p.m., I will not be grounded. Is that the same sentence as if I am out past 10 p.m., I will be grounded? So let's do a truth table to try to figure this out. We have P and Q. We have true, true, false, false, true, false, true, false. We see that we're going to need not P and not Q, so let's do that right away. Not P is going to be false, false, true, true. Not Q is going to be false, true, false, true. And now we have our two statements. We will start with not P implies not Q. And remember, this statement defaults to true if the first piece is false. So in this case, if not P is false, we immediately have a true statement. So we're looking at the not P category. The first two are false. So we're going to have true, true. Now, if true implies false, then we have our false statement. So we're going to have a false here. And then if true implies true, we get a true statement. So we have true, true, false, true. And then we have our, change my color, our P implies Q, which we already did 1 for. It was true, false, true, true. True, false, true, true. And you see, these are not the same statement. The middle statements actually mess things up. So a statement that looks like it could be the same, if I'm out past 10 p.m., I will not be grounded, might seem like it would be the same statement as if I'm out past 10 p.m., I will be grounded. But they are not the same statement. So you have to be careful, and this is where the symbolic logic can really help you with understanding a statement that is very similar to another statement.